Autonomous Web3 systems shouldn't rely on one all-powerful agent. Instead, we split the work across specialists. One researches, one validates, one reviews risk, and one executes transactions. That separation creates safer, more reliable one-chain automation. So far, we've built a progression. Agents that reason and use tools, then agents that connect wallets, sign safely, and interact with contracts. We added DeFi workflows and event-driven automation. Now the focus shifts from one capable agent to several specialized agents coordinating around shared Web3 tasks. In Web3, autonomy is powerful, but mistakes are expensive. A single agent that researches, decides, approves, and executes can overreach, especially when transactions are irreversible. Multi-agent systems reduce that risk through separation of duties. One agent gathers evidence, another validates risk, and another executes only after approval. Each role becomes easier to test, monitor, and restrict, which matters in DeFi, DAO, payment, and security workflows. Think of a safer agent system as a controlled workflow, not a single super employee. The researcher gathers evidence, but cannot move money. The decision agent recommends an action, but cannot approve itself. A validator challenges the reasoning before anything happens. Then the executor performs only a narrow, authorized task. If one role makes a mistake, the next role can catch it, and permissions help prevent that mistake from becoming an irreversible action. The same idea applies across the full workflow. A researcher gathers signals from contracts, proposals, markets, and documentation. A planner turns those signals into possible actions. A risk or critic agent challenges the plan, looking for bad assumptions, suspicious addresses, or failure modes. Only after approval does the executor submit transactions, with strict wallet limits and policy checks. Monitoring then watches outcomes and feeds new information back into the system. At the architecture level, the key is separating knowing from doing. The researcher can query RPCs, indexers, ABIs, governance discussions, and market feeds, then produce a structured recommendation with evidence. It never receives raw transaction authority. The executor gets only validated instructions with exact parameters, and its tools stay intentionally narrow. Before anything reaches a wallet or contract, policy checks, risk review, and permission limits must pass. Autonomy becomes a controlled approval pipeline. To make that pipeline reliable, agents need more than loose chat messages like "looks safe, execute." They need shared state with clear fields: what evidence was used, what assumptions were made, which chain and contract are involved, how confident the system is, and what action is allowed. Keep approval separate from recommendation, so an agent can suggest without silently authorizing. Preserve the history as well. When something fails, structured messages give you auditability, debugging, and safer handoffs. Before execution, a separate reviewer should try to break the plan. An LLM critic can challenge the reasoning. What evidence is missing? Which claims might be hallucinated? What assumptions are too weak? Deterministic validators then check what machines are good at, including contract addresses, chain IDs, limits, spenders, call data, and approval thresholds. If the result is high risk or ambiguous, the safest action is not automation. It is escalation to human oversight. Policy validators form the hard gate between a proposed action and real execution. The planner may suggest a swap, approval, escrow release, or governance vote. But the validator checks explicit rules first: allowed chains, approved contracts, token types, spend limits, and user permissions. If anything falls outside policy, the action is rejected or escalated, even if the model sounds confident. Treat these guardrails like code. Version them, log decisions, and test them regularly. The executor is the last checkpoint before real funds move, so keep it intentionally narrow. It should receive only an approved action, confirm the policy still allows it, simulate the transaction, and request the minimum signature needed. Limit tools to specific contract methods with spend caps, session keys, multisigs, or smart accounts reducing blast radius. Before broadcast, recheck parameters. Afterwards, record the intent, call data, simulation, signature request, receipt, and final hash. Once the roles are clear, the next choice is orchestration. Sequential pipelines are easiest to reason about because each agent hands off to the next. Supervisor-led designs add a coordinator that tracks state and routes work. Parallel review improves safety by asking agents to challenge the same plan independently. Event-driven systems react to one-chain signals, like prices, votes, or alerts. In Web3, the right pattern depends on latency, cost, auditability, and risk. When a system can move money or trigger irreversible actions, disagreement should not be treated as noise. It should become a control signal. Low-risk decisions can execute automatically when agents agree and confidence is high. As value, risk, or uncertainty rises, require additional approvals, voting thresholds, or weighted confidence checks. At the highest levels, route the decision to a human, or reject it outright. Log every escalation and rejection, so governance improves over time. Debugging also changes in a multi-agent system. Instead of inspecting one model response, you reconstruct a chain of decisions. Capture every agent's inputs, outputs, tool calls, rationale, and confidence. Then trace state changes from event detection through processing to transaction confirmation. Operational metrics like rejection rate, escalations, failed simulations, and latency show where the system is drifting or breaking. Finally, preserve audit trails so users, reviewers, and regulators can verify what happened and why. In an escrow release workflow, the multi-agent pattern becomes a controlled chain of responsibilities. An event monitor detects a milestone, then a research agent gathers invoices, delivery proof, and on-chain state. Risk and policy agents independently check the contract address, recipient, amount, deadlines, and dispute signals. If evidence is incomplete or policy fails, the workflow escalates instead of paying. Only after approval gates pass and simulation succeeds can the executor release funds. The core lesson is that autonomy needs structure. Separate research from execution, protect wallet access, and require critic, risk, and policy checks before any irreversible action. With that foundation, agents can safely move toward market monitoring, trading, arbitrage, and stronger Web3 startup ideas.